Carlos, Team 5. It's Balsa experiment. All right. Matt, you want to take the show?
All right. Obviously, you guys probably know the objectives by now. Pretty straightforward. Same as you guys. Let's see. Obviously, less than 5 inches of deflection. Next slide. All right, and the specifications. I'm sure you guys probably seen this once or twice. Next slide. All right, this is what we wanted to do. We want to do a truss system. That's what you're going to see right here, with a lot of bracing on the actual platform itself. I think that if you distribute most of the load out to the edges, then by that time your truss should be able to handle it, which it did, kind of. I made a PowerPoint, by the way, so you can throw that right on my test grade.
All right, Justin, we talk about construction.
Okay, so the actual construction of the bridge. Once we had our initial design, we went with the construction. We started out by framing up the frame for the decking, and as I'll talk about in the failure later, where we messed up is these individual sections. We should have framed it up solid. These right here were solid pieces, and it didn't really matter. There's a glue connection on the ends here because that was resting on the support. But once we got this, and we've got our vertical members here, and this is for the actual frame. We framed the entire bridge up before putting the decking on, and then the internal framing underneath the bridge deck. Once we got everything framed up and the deck on, we were able to flip the bridge upside down and rest the members on the bridge deck. So it made construction a whole lot easier. And the glue we used was called Zappa Gap glue, and we used Zip Kicker accelerator. We really didn't need an accelerator unless we were working on some of the vertical members where, like in areas such as this, we didn't use any tacks or anything. You could literally spray the accelerator on it, put some glue and stick it together, and it was like instantly dry. And do the same thing to your hands if you weren't careful. Okay, this here shows our bridge and testing, and after failure. And like I said before, can you go back to the previous slide, Carlos? We actually braced this here. Instead of what we should have done is use one continuous member here. Instead, we glued segments in, and if we had notched the beams here in the middle, the girders, and run a continuous member, our bridge would have held up a lot more. What ended up happening, the bridge was basically carried by the center span of the bridge, and it just failed at the plane where it was glued down through here. You can get to the next slide.
Well, Carlos, go back 2. Yeah, or 3, I guess. Go back. Go back. And then right here, where we had this bracing, that was for where the rod stuck up. We only did that on the centerpiece, going all the way out to the edge, on the center part. So if you go ahead and forward. So if you look right here, we did it on this section right here. What we should have also done is done it just the whole length down, but we ran out of wood. They were closed. So you can kind of see where the failure happened. It didn't distribute the load out here too much. It kind of just was held up by the middle. That's what we just
So basically, we had one wood beam, and it was a thick member, right in the middle of the hole. And yeah, sorry about that question, guys. It came out all wrong. And that's what. And we had, that thing weighed 700 some grams. I think we held maybe 100 pounds. That's a fraction of what.
No, we have more than that.
Okay, well, it was the weight,
It was like 140 kilograms. So.
Okay, well, the strength to weight ratio was awful, so, and that was all in our design. Obviously, but looked good, looked nice, you know, weighed a lot, cost a lot. Not fishing privilege.
Any questions? Whenever there's a question, I'd like you to answer so that you also participate.
Yeah.
Questions? We have room for 3 questions.
For the truss, why do you have this extra? I mean, I feel like you have redundant.
Hey.
I'm just asking.
Well, we were trying to resist the buckling when the load was applied in the middle, and it wouldn't come up. We were just trying to
So it's used to reduce buckling?
yeah, the compression forces in the center.
Did you use same cross section for all your members, or did you vary the cross
Yeah,
section?
they're all the same cross section.
Would you do it different? Would you change the cross section next time if you build the bridge? Again?
No.
Really?
I mean, you know, you're restricted with, you know, the kind of material you can buy.
I really think it'd be a difference night and day if we'd have run a solid member across, because like I said, it failed along everywhere. It was glued down that center span and just broke away right there, and the entire deck went with it.
What ended up happening was when we were building the bridge, it didn't exactly. We started adding stuff to it, so you can kind of see like right here was planned and right here was planned, but then we were like, well, we had a little more length to work with, so.
Carlos, how do you describe this failure? So exactly, can you explain what happened here?
Oh yeah, it was like the bottom is a one-way slab, and like the load was concentrated only on the center instead of being like spread out in the whole area. I think if it wasn't concentrated, it would hold more.
So you couldn't transfer the loads from the slab
Yeah,
here.
so it would have made the center piece stronger only.
You needed some strong transfers.
Yeah.
Perfect. Thank you.